happy, and I'm not sure it does that. We still continue to engage in customs involving holidays and festivals all over the world, all kinds of different things that we celebrate that aren't of really very much importance. Um, Certain cultures continue to engage in what we call puberty rites, bar
Our
mitzvahs,
target,
bat
but in
mitzvahs.
MS Control, it's very far from the target. And you may see the same results for 32 second and 58 second. And the difference between MS and the healthy control people was significant.
Okay, thank you.
Just say a few words.
That's it. Thank you so much for joining us. That's Ram Singh.
Thank you.
With that, now we are moving on to the next session, that is by Elias Iran Khan and Iman Bagari from Kairan Institute of Higher Education, and they're going to speak on early diagnosis of epilepsy with the help of analysis and processing of MRI, images and brain signals. So I'm sharing the screen, Elise and Iman. You can start your session.
So Shirley, hi, I hope you're doing well, and hello to dear professor. Thank you for dedicating your time for our presentation, and now we are gonna speak about epilepsy disease and early diagnosis of epilepsy with the help of analysis and processing of MRI images and brain seizure. A seizure is a sudden, uncontrolled electrical disturbance in the brain. It can cause changes in your behavior, movements, or feeling. Actually, if you have two or more seizures after this slide, my dear co-author Iman is here, and he will be continued this presentation. And thank you so much.
Okay, thank you for dedicating the time, and I really say warm hello to the professors. So, regarding the methods in diagnosis of the epilepsy, optimal processing of the optimal EEG brain signals, that it's a kind of combination between the image processing on the MRI and the signal processing on EEG signal, electroencephalogram signals. What we're going to perform is a combination of image processing and signal processing using the LMAN, a neural network for signal processing, of course, and the multi-layer perceptron neural network for image processing. The person is in normal thing. I mean, this is not experiencing epilepsy or seizure or something like that. I mean, the family of seizure, which is epilepsy. As the signal is very chaotic, it is a kind of normal signal, a normal EEG signal. But when it comes to talking about it has some patterns, the seizures is going to happen. So segmentation in the diagnosis of epilepsy regarding the previous equation that we performed as comparing to the normal cases and the mild and the severe cases, we can see that these are the scattering. These scattering dots are the signals that we receive and the amplitude of these signals regarding the points that we achieve them in terms of time. And calculating conformity using the formula given that is in terms of frequency, that you see this is a kind of positive value and it is also even, indicating the fact that how similar is these values together, and the horizontal value is considered for the frequency, and the vertical value actually is called for the similarity. So using the phase difference, it can be very useful for the phase difference measurement, I mean the conformity. And going back again to our research and the data that we received through that, these figures are performed using MATLAB. And you see that the top one is for the normal person, the middle one for the mild person experiencing epilepsy, and the last but not the least important, of course, a severe epilepsy scattered. So this is also indicating our previous mentioning. So going to the next slide, please. So this is another important feature that we are going to describe here, the return map. So the aim of return map is to find a hitting point, of course, showing the similarity to the current, previous, and the next samples of the EEG. And using the return map, we can actually have some shape features, such as how periodic is the signal. Is it, for example, non-periodic or semi-periodic or even chaotic? And parameters like trajectory of the system in state space, and of course quizzing points that are important, of course indicating that how the system works by analyzing the return map. As you see in the right side, we have two figures. That one of them is indicating actually a visualization on a line between a normal and mild and the severe, according to our data that we performed in our research. The 3D visualization interpretation shows that the samples on the line and the longer distance is, the less chances of epilepsy is going to happen. And centralized and circularized in the phase figure that we have in 3D in the right and the downside, we have the blue actually curves that we see that they're circularizing and going to the center. Deep in the details of the centers, as we go deep into the centers, we have more similarities found in the return map, which increase the chances of epilepsy in the people. So among this part, we finished actually the signal processing, and then we're a little bit focusing on image processing, and then coming back to compare both of them. So regarding the image processing of MRI images, we have the binarization of the image that can create a kind of thresholding the image that the gray values will be converted to 0 and 1 and to black and very light, very white. And then we have the noise reduction filter that can be very useful. As you see, the right photo has some noises. Noises are defined and the multi-layer perceptron that we performed for the EEG signal processing and the MRI image processing for MRI images. We're using neural network architectures. So generally, deep inside the neural network, we have generally two layers, including a recurrent layer providing feedback from the first layer output. So we have feedback from the layer output, and including some hidden layers between them. And the recurrent structure that we have, the definition of the recurrent structure indicating and demonstrating the fact that we're updating the weights. So weights in the neural networks are updated after getting feedback from them. So based on the number of neurons, there are features in the hidden layer. So as we increase the number of neurons, we increase the features in our layer. So in the final results and conclusion, epilepsy sudden, it means, as a definition, it means sudden transmission of huge number of neural messages that are coming to the brain. And the most important truth about it is the fact that its originality is something that we can confront as an obscure and something that is unknown phenomena. And brain signal analysis using the L-MAN neural network is performed. And then in the image processing part of our research, we performed on the MRI images using the multi-layer perceptor neural network. And the statistical features that used here are central, in terms of central are mean, here arithmetic mean, mode and median. But the one that has the more effect here is the mode in the statistical features regarding the signal processing. The least values, which is really important for us, is the gamma here. In terms of the gamma frequencies, indicating more variance and other statistical features, especially for the L-MAN neural network and the extracted features. The statistical features related to the EEG are really important for us, and it can actually provide these features, the nonlinear features for phase map. Phase map is also another name for the return map. So we have the statistical features related to the MRI images as well, and regarding the calculation of the accuracy results among these three groups of people, the categories, the classes of people. We have again normal and mild people. We compared them normal and mild, normal and severe, and mild and severe results in a table that indicating that when we are only using the signal and signal processing technique, and we are using L-MAN neural network, we have the normal and mild people, not experiencing epilepsy, that shows the accuracy of 73.8%, and comparing them to the normal and severe, we have 78.2, and mild and severe 72.9. We will discuss about the interpretation about these values. And then when we have the image, we have 81, 84, and then the other results. That the most important thing is that when we are using at the same time signal and image, it doesn't mean that we are using both image and signal. We are receiving the fact that whether a person is experiencing epilepsy or not. We know that, for example, someone has epilepsy by the input signals that we receive and the input values that we have. We see that when we are using signal and image at the same time, and I mean it's kind of or between them, we have better results that we have at that table. Thank you very much for dedicating the time, and I'm waiting for any questions that you
Thank
can
you.
ask.
Thank you so much for both of you. So I request other speakers have any questions to Iman and Alice, they can ask now.
I have a couple of questions and an idea. So let me start with what I think is less important. That's your statistical analysis, because at the end of the day, it's the big idea that's more important than the stats. So your analysis was based on FFT?
No, it was not based on FFT. It has frequency, but it is not fast Fourier transform. Definitely not indicating the fast Fourier transform that you are mentioning right now.
No, because you didn't say that. And if
we're talking about FFT, I know.
I would have given you a whole thing about Hilbert transforms, but
Okay, sure.
I don't want to get into that. The second thing is you have a model. It's a two-layer model.
It's a kind of, no, it has more than, I mean, the most important thing is the first layer and the last layer, but there are some hidden layers between.
Yeah, because the brain is more than that.
Yeah, of course.
The third thing, and these are the technical questions, then I have something which is a suggestion on top of that. The third thing is your stats are based on median mode, excuse me, median mode and
Range, you mean?
what was it?
Yeah,
Yeah,
mean,
right.
mean and median mode, yeah.
what did you do about
Mode, as a definition of the mode, yeah, I'm going to answer. Is your question finished?
No, I was going to say, what are you doing about the homogeneity of variance? Is it homogeneous? Is it heterogeneous? In other words, these are multiple factors in there, so is descriptive statistics the best way of getting into it?
Yeah, of course, homogeneous, yeah, and yeah, of course, these are really important to be noticed, yeah, and to be considered, of course. What we performed regarding the fact that why we are using the mode that has the most significant effect here is just by the definition of the mode. So what is the meaning of mode? You know, when we compare it back to for example, the median means to select the middle signal. When it comes to mode, it means the frequency of happening. So what is important in the epilepsy, what matters to us is how frequent it happens, I mean, in terms of signals, and how scattering is in terms of line or the phase on the phase map, that how centralized are them. So what matters, the most important feature here is mode and the repetition of these things. When they are repeated too often, and they are centralized, or maybe in a line that are just I mean, in terms of dots that we receive in terms of signals, it shows that we have epilepsy. But as they are scattered and they are chaotic, it shows that the person that is experiencing not epilepsy, or maybe very mild epilepsy. That's why we perform this.
Now the presence of it. Now my point.
Yeah,
So now that you know what epileptic activity is, you now have a binary algorithm, which is it there, is it not? And who cares from which leads? Your object is to make a frontal lobe decision to turn it off.
Yeah, exactly. And we're performing accuracy about that, and which is not just limited to 0 and 1. I mean, the binary, just to dedicating the fact that whether someone has epilepsy or not, we are calculating and predicting and anticipating the fact that how prone he is to have epilepsy. That's what we perform.
This is the next step. What you've got in your hands, I believe, at least as I understood it,
Thank you very much.
is the decision of you don't have it. That's more important than you have it.
Yeah, exactly. Yeah, this
Because
is
that
important, yeah.
allows you
Because
to
that
hook up.
person could be clarified about it, that okay, thanks God that I don't have epilepsy, and I don't have any chance in the future that I become, I don't know, prone to epilepsy or experiencing this. This is what we actually, our team actually performed.
It's a potential great contribution
Thank you.
to do that.
Thank you very much.
Okay.
Thank you so much.
Well,
Is there any other question that you would like to ask, or any other members that would like to ask?